This doesn't happen very often, it happens once every 5 years. The longer it takes for it to happen, the more severe the El Nino is. Which is why in 2015, which I'll show you in a minute, you might have it next, we had a severe El Nino, as you can see. That's what an El Nino looks like when it's severe. So much heating, and of course this warms the global temperatures immensely. So much heating and energy over here, so all the low pressure goes to South America. This one was particularly severe and so strong that it actually warmed the temperatures in the Indian Ocean as well, and all of the water around Australia. So we didn't actually do too bad from the El Nino in 2015-16, but we did with the temperatures. It was extremely hot. Okay, so our spring was severe here. We had obviously rainfall deficiencies and very warm temperatures. So it actually, the East Coast did very well during the 15 and 16 El Nino because of that warm water there. And a little known fact, after an El Nino, the warm water goes into the Indian Ocean, and this was all based on my forecast last year. That warm water creates a negative Indian Ocean dipole, and that gave us the wet 2016, which I forecasted last January. Somehow climate models didn't see that coming at all, and still had a drought up until May last year, as some of you would know. But that's what happens after El Nino. So that's why the year after El Nino is always very wet in Australia, particularly southern Australia, because of the Indian Ocean. So you can see how much that heats the globe up. That's just a release of heat. Normally 3 months later, you get a response in the temperatures. So whatever that's showing now, 3 months later, you'll get that response with the weather, basically. La Nina, conversely, is the opposite. All that is a strengthening of the easterly winds. So by strengthening the easterly winds, we bring up immense cold water out of Antarctica, which is the Humboldt Current, which runs all the way along here and up the coast, and brings that cold water this way. So in essence, what it's doing is creating high pressure here, low pressure over Australia. The last one we had obviously was 2010-11, and we all know how that turned out. That turned out severe because it was so strong. That was because that was actually a weak, milder version of a very strong La Nina. So that's basically what drives the climate, La Nina and El Nino. The other thing too is all these temperatures we see here, apart from the weather creating them, the heat is stored in the oceans from the sun. Okay? Now, you don't just have one hot summer and it causes this. This is hundreds of years of energy put into the oceans, hundreds of years. We don't actually know how much, and I'm reading papers all the time. We're getting new scientific papers being released and doing new research on this. We just don't understand how long the lag is. It could be 100 years, it could be 200 years. The best guess is a couple of centuries. Okay? You think about it, the oceans are 1,000 times more, they hold 1,000 times the energy of the atmosphere. So it must be hundreds of years of energy put in there by the sun. So basically it heats the earth at the equator, and then it tries to cool the earth down by getting that warm air at the equator to the north and south pole, and it creates the weather that we see every day.